book, so you need not worry about it.
Great. I'll do
Okay?
that. Yeah.
आपके लिए सब रेडी किया क्योंकि मुझे मालूम है आपकी अभी your schedule. I can imagine that. मेरी भी हालत वैसे कुछ अच्छी नहीं है. ठीक है.
I know you are a different ball game altogether. I never stop being enamored with how you work. Absolutely.
पानी है, बह रहे हैं और क्या करेंगे यार?
हाँ, वो तो है.
Simply put.
वो तो है.
Okay, girls, I think, no, I'm still not seeing the live active, but it is almost come. Yeah.
This same meeting is now streaming live on YouTube.
Yes, we are live. Yes, I can see we are live. Just give me a moment. As you know, Sonia will have to share with the group and then. So usually it always becomes this Indian IST. Bit worried about it all the time, but it's okay. So while you both will be talking, I will put it also in the LinkedIn. Not now. We should get started at 5. Okay. Due permission, shall we start? Both Meghna and Sonia? Yeah? Okay.
Yes.
Great. Warm greetings. Welcome to another session of Friday Waters Thesis Club. Today, Friday Waters Thesis Club session is on flushed but not forgotten, evaluating risks to water quality from everyday chemicals. And we have with us Dr. Meghna Kappa. Before we invite her, let me just go through briefly Friday Water series and what we do here. The Friday Water series is an extension of our flagship program, Wednesdays for Water, of the W4W Foundation. The idea of Friday Waters is to wet the Fridays with fun-filled and yet fruitful activities for the future generation. Friday Water series has water talkies, book reading, water arts, thesis club, which is today, and meet a maestro, and some of them takes place every month depending on our speakers' availability. The focus of Thesis Club is on bringing students and scholars who have done or are doing some research on some aspects of water matters, and we bring them into the session in order to discuss with them the identified problem, the aim, objectives, methodology they used, the research design, field work, findings, and learnings. We are very proud to say that over 35 students have actually PhD scholars and postdocs have presented here, and many of them have used it actually as a place for their final defense as well. In the process, the idea is to make the research and their contribution in the science and society available to larger set of people, including our past, I will say, speakers, and also make the researcher acknowledge the work she's doing and also bring her to our little water community we have made. This is Mansi Balbharga from the House of W4W and also the moderator for today's session. And I'm joined by Professor Sonia Gupta from Buxton University as a discussant for today's session. Thank you, Sonia. You have been a good pillar for me, standing alongside this thesis session and taking it along. For today's session, I hand it over to you, Dr. Meghna Kappa, who will present her part of the PhD research, Flushed but Not Forgotten, evaluating risks to water quality from everyday chemicals. From here on, it's over to you, and welcome, Meghna. Thank you so much for agreeing to do this session, and it was really nice to have you in the pre-session and learn about your work. Over to you, Sonia, and take it over from here. Thank you.
Thank you so much, Mansi. It's always an honor to be somehow associated with this great movement that you have begun. Like I was just saying, don't know how you do it, but you do it very, very fine. So yes, another session of the Friday thesis. Yes, I will first introduce Dr. Meghna Kappa and then also talk about the rules of the game. And thank you so much for sharing a presentation already in advance so we could have a quick look at it. So to introduce Dr. Meghna Kappa is a postdoctoral researcher at Virginia Tech University, Washington. Originally from Hyderabad, where I'm stationed right now, she received her PhD in environmental engineering from George Mason University in 2026. She has previously worked in areas such as water, sanitation, and hygiene, known as WASH, environmental justice, and solid waste management in India and the United States. Her primary research interests are in understanding emerging contaminant mixtures in water and wastewater, and the fate and transport of these contaminants in natural and engineered urban water systems. With this, just basic rules of the game, you will have about 20 to 25 minutes to present. And after that, we will come in with some questions. It could be from me, from Mansi, or maybe some questions could also be coming in from the YouTube channel. And with that, I will ask you to please take over, Meghna.
Sounds good. Just confirming again that my audio is fine.
Yes, thank you.
Okay.
It's working.
Thank you. Thank you, Sonia and Mansi, for the introduction and for bringing me into this community. I'm going to just quickly share my screen. All right, so the slide that you should be seeing right now is the introduction talk to my slide. Flushed but not forgotten, evaluating risks to water quality from everyday chemicals. My name is Meghna Kappa, and I am a recent PhD graduate from George Mason University. So I just wanted to acknowledge that all of this work was done during my time there. It's very nice to meet everyone who's here on this call, whether you are watching this live or later on. So my thesis initially was titled a little bit differently. I modified the name for this talk, but the main focus of my thesis was to evaluate risks in both centralized and decentralized wastewater treatment systems, and I'll go into a little bit more detail in the following slides. So part one of this talk is focused on centralized wastewater treatment systems. That means you are all of the wastewater from your home it goes down a central drainage pipe and is collected along with wastewater from other households and treated at a central location in a treatment plant at a large scale. So this is the main hypothesis that I started my research with. I just want you all to focus on two terms, that is secondary wastewater treatment units and dissolved organic matter, and I'll go into explaining why those are important. The main research question was to find out what the relationship is between DOM, which is dissolved organic matter, and phthalates, which are our contaminant of concern in the first part of my thesis, and how they interact with each other and how that affects the efficiency of treatment of phthalates. So phthalates, what are they? Let's get into that first. We all know about the ubiquity of plastics. They are in all of our personal care products come packaged in plastics. All our pharmaceuticals come packaged in plastics. Cleaning and laundry chemicals. Every single consumer product that we use comes packaged in plastic. Recent estimate shows us that worldwide plastic production stands at 400 million tons annually, and we all know that it's only increasing year on year. Which brings us to the question, what are phthalates? So these are known as the everyday chemical, and how they are related to plastic is that they are the most common additive chemical added to plastic products. Here on the right side, I have a list of all of the different phthalates. So a phthalate is not just a single compound, it's more of a chemical class. So there are different chemical structures in the group that we call phthalates, and they range. They have a range of physical and chemical properties, but their main use is to make the plastic product flexible. So flexibility is the main property that they induce into the plastic. Some of the recognizable uses for phthalates are actually in cosmetics, perfumes, and nail polish, and sometimes in pharmaceuticals. So I was saying earlier that they are used in packaging, but sometimes they are also part of the main product. So, for example, some of the lighter weight phthalates are very good at carrying perfume fragrances over long distances. So sometimes they are added as an ingredient itself, although in very, very small concentrations. Other uses include at a macro scale PVC pipes, which is all the way at the bottom here. PVC pipes, medical tubing, food packaging, any plastic that you see in your life that has a flexible structure, you can assume that there is phthalates in it, either during the manufacturing process or in the product itself. Right. Next slide. So, since we are talking about the relationship between phthalates and wastewater, we must know what happens to flushed wastewater. So, all of these chemicals that we flush down our toilets and laundry spaces and hand wash and showers, they are all directed to a centralized wastewater treatment plant. In the US context, there are certain minimum treatment standards for or quality standards that the treated wastewater is expected to meet, and those are regulated by the US EPA through the program called National Pollutant Discharge Elimination System. So the NPDES is what regulates how clean your wastewater is after it goes through treatment. And then depending on the level of treatment, there are, broadly speaking, conventional and advanced wastewater treatment plants. If the treatment level is advanced, then the treated wastewater can be directly released into a river or a stream. But otherwise, that water ends up finding alternative uses. So, for example, one popular use here in the US for maybe substandardly treated wastewater is in golf course maintenance. So it really depends on the capacity of the treatment plant and how well it can treat the wastewater. But the problem that we want to focus on, which was the focus of my thesis, is that there have been several reports across the world that in treated effluent, we are finding concerning levels of phthalates. And why wouldn't we, right? Because they are present in almost every product that we use, and they are easily able to leach out of plastics because they're an additive and they're not chemically bound to the plastic polymer. So you might have heard on Instagram reels while scrolling, hearing from your favorite health influencers that heating a plastic box in the microwave is bad for you. That's because chemicals like phthalates can leach out into your food. And so phthalates don't really need much heat to leach into your food. It can happen even passively at normal room temperatures. So you can assume that even all of the other products that we use are going to release phthalates. So if your shampoo or any other product says no phthalates added to the product, it's still possible that it's leaching from the packaging. So naturally, a wastewater treatment plant is not usually designed to treat these contaminants that we are so concerned about these days. So there are several reports across the world that we find phthalates, which is this little molecule here, in treated wastewater effluent. So there are some toxicity concerns related to wastewater discharge because a lot of these chemicals are not treated well enough. I'll just quickly go through this. The main effects of phthalates are endocrine and reproductive effects. So they affect how hormones are produced and circle through your body. This has been observed in both aquatic organism and even through epidemiological studies in humans, which is why it is very important to understand why phthalates are not completely removed in the current wastewater treatment strategies that we have. So a typical wastewater treatment plant has primary and secondary treatment. I just want to direct your attention to this box on the left. Mainly, you want to think about your human wastewater as containing chemicals, organic chemicals like this, like the phthalates, and then human fecal matter, right? Everything that's the brown particles of different sizes. And size is important here because that determines how the phthalate interacts with all of the fecal matter in present in wastewater. Lot of technical details here, but I just want to reiterate to focus on this picture and these two questions that are highlighted. So as you can see, there are a lot of heavy particles, a lot of lighter, smaller particles. So the main question here is, are the phthalate levels in treated wastewater related to these, human fecal matter and dissolved organic matter, as we call it in technical terms? What is the relation between them? Are the treatment efficacy for both of those, are they related to each other? And how does that relate to treatment improvement in the future? So the main hypothesis was that residual organic matter in secondary treatment units, where there's a lot of biological activity, is binding with phthalates and facilitating their breakthrough. So basically, what my hypothesis says is that the plastic product or whatever you're using is leaching out these phthalate molecules, right? And it is going into your huge wastewater sample from all the city's wastewater, basically. So now you have all these brown fecal matter or dissolved organic matter particles of different sizes. And the basic tenet of organic chemistry I just want to put here, which will help a lot of people understand what's happening, is in chemistry, opposites do not attract. Actually, like attracts like. So human fecal matter is also organic, and phthalates are also organic chemicals. So there is a certain affinity towards each other because like binds like in chemistry. So that is the main mechanism, the binding mechanism that I have been trying to study here. What inspired this research is basically the hypothesis that the phthalates are binding with the lighter material, the lighter organic material, and then because of that, they don't settle down to the bottom of the tank in a treatment unit. Generally, what happens is that all of this sludge settles down to the bottom and is just scraped away. But if phthalates are binding to the smaller organic matter, then they don't settle down by gravity because they are lightweight. So they are going to flow all the way out of the treatment tank, bypass all of the treatment steps, and that's how they end up in your treated wastewater. So they're almost bypassing the entire system that you've designed to treat these chemicals. This is some evidence from literature in stormwater sample contexts. So dissolved organic matter is a very big umbrella term. We can talk about that in even natural water context, but this thesis focused on wastewater dissolved organic matter. So this is just some previous work that was done that again inspired my hypothesis. So now that we have enough context for that, I'll just quickly jump to the methods that I've used. I've collected samples across different stages of treatment from a local wastewater treatment plant. I filtered them because I wanted different sizes of organic matter and phthalates. And then I analyzed them using these instrumental techniques. So GCMS stands for gas chromatography and mass spectrometry, and fluorospectrometry to measure the dissolved organic matter. And once I have data from these two, I basically try to correlate them and find patterns in the different binding mechanisms of phthalates and the different DOM sizes or dissolved organic matter. Some preliminary results, I won't go too deep into this because it's still under review for publication, but generally we found that the trends are showing us that in samples filtered with different filter sizes, there are certain differences in phthalate and DOM binding. So for example, when you filter using a smaller pore size, we see that the phthalate levels are slightly lower that we measured, which means that some of the phthalates are binding with, particle sizes that are between 0.2 and 0.7 microns. What is important to take away from here is that it is important to know the size of the dissolved organic matter that you're dealing with at each stage of treatment. So for example, this is at the earlier stages and this is at the later stages, and it does make a difference what we are measuring and what filter size we are using to evaluate our sample post-treatment. Yeah, so that's the main takeaway from there. And now we come to the characterization of dissolved organic matter. I know there's a lot of noise going on here, but this basically tells, this is an example of what a result would look like from a fluorescence spectrometer. We are basically using these signals to approximate a chemical structure for the dissolved organic matter because it's a diverse group. As you can imagine, if you are flushing a lot of things down the drain, there isn't a certain single standard chemical, composition for it. So we need to, this is a crude way of characterizing what are the main components of your dissolved organic matter and how likely are they to bind with chemicals like phthalates. Quickly bring us to the implications of this study, because we do have a part 2 to this talk. So the main takeaways from this research were that we do need increased phthalate monitoring in US wastewater treatment plants. From what I've mentioned, though phthalates are ubiquitous and used in all plastics, the monitoring levels for phthalates are pretty low at the moment. And this has to do a lot with the regulatory landscape in the US. It's more of a innocent until proven guilty type of scenario in terms of regulating chemicals. So phthalates are definitely getting increased priority, but they are not there as yet. And landfills, where a lot of our solid waste, which contains plastic, goes, can be an important source for phthalates in the environment. And also, fluorescence spectroscopy can be a useful tool for understanding the more granular details of how phthalates interact with dissolved organic matter. And that is a summary of part 1, where we talked about centralized wastewater treatment systems. And now we are jumping into decentralized wastewater treatment. So I'm sure a lot of people are familiar with the idea of a septic tank, but this is basically an individualized treatment unit. So all of your household waste goes here. And what happens here, again, as you know, in whatever we flush down the drain, there are solids and liquids. So the solids will settle down to the bottom of the septic tank, and the liquid waste is pumped into the what is called a drain field. And it's basically just pumped into the soil and hoped in hopes that the soil will treat whatever the wastewater is infiltrating through it. Now, because of the complex nature of whatever we are flushing down the drain, obviously there are different levels of treatment for different types of pollutants. So we have obviously viruses, bacteria, nutrients, meaning nitrogen and phosphorus, organic micropollutants like phthalates that come from failing septic systems. And honestly, they don't even have to be failing. Even properly functioning septic systems are still releasing these chemicals by soil infiltration, which reaches your groundwater table and then eventually reaches surface water flows, which means rivers and streams. So just a reminder about our organic micropollutants of concern. We spoke about phthalates. Now, in this part of my research, I focused on different group of chemicals called pharmaceuticals and personal care products and per and polyfluoroalkylated substances, or PFAS, which have been in the news lately. You might know PFAS most famously as Teflon, which is one of the different types of PFAS as non-stick coating. Any product that has non-stick features is likely has PFAS in it. So that's just for your reference. So these are some of the previous studies from literature that show us that septic systems, especially in areas that are served exclusively by septic systems, can be susceptible to septic related pollution in their streams by way of under the ground transport of these contaminants. So this is a really good representation of what's happening there. So why must we identify and monitor septic system pollution? Because we need to protect our drinking water sources. So if we just go back and see this, all the contaminants that are traveling from below the groundwater table and reaching a river, for example, that river is being used to provide drinking water for large populations. So if we are finding all these complex contaminant mixtures, then we really must have really advanced treatment infrastructure so that we remove all of these in from our drinking water sources. So that's one of the most important reasons. And toxicity wise, harmful health effects are possible at very continued exposure. And since drinking water we are exposed to every day, we're drinking hopefully several liters of water every day. Even at low concentrations on continued exposure, we can experience harmful health effects. Some of these include endocrine or hormone disruption, reproductive effects, and increased cancer risks, as put out by the Centers for Disease Control in the US. So that brings us to the main research question for my thesis. How much of the micropollutant load in our watersheds can be attributed to septic systems? So I just want to quickly show some preliminary data that we collected. For reference, all of these dots that you see on the map are all septic system locations. And here is where we sampled from. And this is a little bit downstream where if you assume that all of these contaminants are traveling all this way, there is some dilution that happens here and you may see lower concentrations. So we do observe that a little bit where at least for the pharmaceutical compounds, closer to the septic system cluster above, we saw some higher concentrations of pharmaceuticals, whereas in closer to the reservoir where there's a lot of dilution from this large water body, we are seeing lower. But again, the trends are not straightforward for different chemicals. We see the opposite trend for PFAS. Now that has to do with how chemically different they are. Sometimes some chemicals are more likely to get absorbed by the soil while they travel through the water table. They can get bound to solid particles and just remain there. So for example, if the contaminant is released here, some chemicals are likely to travel faster just by virtue of their chemical and physical properties, whereas some just stay there. So a lot more deeper analyses are underway to figure out more robust methods to definitively say that in septic system clusters we are seeing these certain chemical signals, and therefore we can say that septic systems need better design and more regulation. So this is just another example of correlation between the different type of chemical classes that we find. So this is just an example of what it would look like to analyze this kind of data further. So Because these chemicals have very specific uses, we can use that their like co-occurrence as a signal for certain sources or origins of their pollution. So, quickly jumping to the implications of this work, we did find pharmaceuticals, personal care products, and PFAS in all of the stream samples that we measured from across 6 or 7 sites. And we've designed this sampling campaign in a way that there are no other major sources of these pollutants. So, for example, we have sampled upstream of wastewater treatment plants, and industrial facilities, airports, landfills. So we made sure to rule out all of those. And in future work, we will do some additional sampling and characterization to understand concentration levels and how they correlate with each other. There's also a big geospatial component to this because of the under the ground transport of these contaminants and its relation to the local geology and hydrogeology. So we have some other team members that are working with me on this to figure out how to correlate these PFAS and PPCP levels to the various watershed features. And that brings me to the end of my talk. Thank you so much for listening, and feel free to contact me via email for any questions that you might have. Thank you.
Thank you so much, Meghna. And I must say that I am still struggling to pronounce the first word, but I did learn 2 important words today. And the first word you have to help me pronounce. Probably Sonia will do better than me, but PFAS. But I'm also conducting a plastic pollution study, but it's not on the nano or I think emerging pollutants that you're talking about. Sonia, over to you. And then this is also a time we invite all our participants to post their questions in the chat box or raise their digital hand while Sonia is ready with her questions.
Thanks, Mansi. Yes, so like Mansi said, pronouncing it was a little difficult, and you helped us with that, Alex. So I don't know, the first question that would come to mind is that what brought you to even imagine that the possibility of everyday chemicals can get through the water treatment systems?
That's a great question. Thank you. Thank you for that. So before starting my PhD, so all of this started, the inspiration started in my master's program at Duke University. I took a course that was called Environmental Organic Chemistry, and that was my first introduction because I come from a civil engineering background. So there was a lot of design and process engineering, but not so much chemistry. But in my final semester, I took this course, and that was my first exposure to learning about like the chemical composition of the things that we use every day. And following that, I worked a little bit in solid waste. The organization that I worked for is a leading institute in funding solid waste research. So as part of the onboarding process, they made us do these orientation courses that they had developed. And there I learned all about landfills and landfill management. So I was just putting those two together, just thinking about, I was anyway always obsessed with the thought of how much plastic we generate on a daily basis. And honestly, it seems much harder to remain plastic free in the US than it is in India. And so that thought really consumed me. So there also isn't a lot of phthalate research in the US. There is plastics research, but phthalate as a plastic additive, there isn't much around it. So I just put those three together, and part of being obsessed with that is why I started applying to PhD programs, because I wanted to work on this in detail. And I was like, if we are putting so much plastic in landfills, then surely there has to be some downstream effect of it. So that's how this journey started. And I pitched this idea to my PhD advisor, and She was excited enough about it, almost as excited as I was. So that started my PhD journey. I was her first PhD student. So in the beginning, we had a lot of freedom to, explore new ideas. So I think it was a combination of luck and, support.
Wonderful. And when I actually saw your presentation, I could sense a chill around my heart because I saw that they are present in baby products, in cosmetics. It's just too
Yes.
unnerving. Yes. So, are there any disclaimers on products like cosmetics and detergents that they're like you have in food items? You have disclaimers for allergens, right?
Mm.
Dairy and nuts and stuff.
Yes.
Are there any disclaimers like this?
Yes, there are disclaimers. So about the baby products, they are regulated. They are banned. Phthalates are banned in baby products, at least in the EU and the US, as far as I know. But of course, there's a huge unregulated plastics industry that we have no idea what they put inside those. Um, can you please remind me the second part of your question?
Yeah, I'm just wondering if there are disclaimers, and if there are disclaimers, then what do they look like? What do they say?
Yes, actually, one very pertinent example is if you've seen Himalaya face washes in India, they say no phthalates, no parabens. Next
Right.
time you purchase Himalaya products, you may want to look into that. But so there are certain disclaimers, but again, these are for the ingredient list. But the phthalates still might be present in the packaging itself. So it's still possible that it's leaching out of that. So it's really hard you have to dig really deep to find out what type of plastic the container is made out of and how likely is it that they would have added phthalate to the plastic packaging during the manufacturing process of that. So there's multiple layers to it, but there's certainly a lot more evidence coming out about the reproductive effects in humans from phthalate exposure. So I think we can expect in the next couple of decades, at least in the US, even with microplastics research really taking up speed, we might see hopefully some more regulations on phthalates as well.
That's heartening that we should be able to, and of course, the world being what it is, I don't think that the research or the findings and their results will take a long time to travel from one part of the world to the other. So that's happening. So, I mean, we talked about disposing them. So how do we, if we are not going to, like detergents, right? Soap, all cosmetics, which face wash, or if they will obviously go down the drain, the wastewater drain. So how do we dispose of them if we are not to flush them down the drains, the wastewater drains? Yes.
Mm. Yeah, this is we obviously don't have any other option for
There is no
disposal.
good way. There is no
Yeah,
good way.
so yeah, I think it's I don't know which is more difficult, whether to stop asking people to use certain products or to place the responsibility fully on manufacturers. But it's obviously going to be a little bit a mix of both, depending on what part of the world you're in. But as I see it today, um, there are a lot of wastewater infrastructure upgrades that need to happen. I know that there's a lot of technological advancement here in the US, but other parts of the world may not be, because again, like we need to think about acute versus chronic risks. So if we are still battling things like typhoid and dysentery and waterborne diseases, then phthalates are obviously going to be much lower on the priority list. So we must first solve for microbial safety, and then we can go on to chemical safety. So it's really about balancing those.
Correct. I understand what you're saying because those will be very prominent and immediate. the
Yes.
microbiological contamination. And this will take so much time and slow that you won't know. Mansi says there are no good or bad devils. Of course, there are devils are devils. That's the description. So yeah, your research talks about these tiny materials, invisible materials that can help carry the pollutants, right?
Yes.
Like you
Yes.
said, they will bond with the like meets like. Is there any way this bonding can be broken?
Yes, that's a great question. And I was hoping that this research would lead to answering that, but we're not there yet. There are certain treatment unit processes that are specifically involved in breaking up those bonds, but they need improvement. And that's partly because um, it's like a mix of an age-old problem with a new problem. So these tiny, we call them colloids because they don't settle down by gravity. So because they're electrostatically charged, so they like to just buzz around inside the water sample. So that physical property of theirs is exactly what makes treatment so difficult. And in fact, while I was writing up my thesis, I found a paper from the 1960s based in the US where they were still trying to figure out how best to remove colloids way back before when PFAS and phthalates were not a public health issue yet. So yeah, some of these older problems have not yet been solved. It likely involves, adding a counter chemical for reducing the electrostatic charge, so maybe it can settle down quicker. We also have additives that's called like a coagulant. So it basically brings all these small parts together into a bigger mass, and because of that bigger mass, it helps to settle down, and then you can just scrape it off from the bottom of the tank. But those again have downstream effects. If you're adding a chemical to treat it, then you need to deal with the sludge that it generates. So there's a lot of cost involved in that for wastewater treatment plants. So right now, what's happening in the US is PFAS are a lot more under fire for regulation compared to pharmaceuticals or phthalates. So the focus is all on one chemical class, which makes it a little bit easier for operators and technicians to focus on, because if you're focusing on one chemical property of a class of compounds, it's like many birds with one stone. But what happens to the other mixtures? Well, you just wait for them to get regulated and then you start acting on them. So,
Right. So something about the regulations. I do have a question popping up in my mind. I'll just save it for later. Something about regulation. So obviously these pollutants are going through, right? So are regulations falling back? Are they outdated? How is this happening?
yeah, so I don't. The regulations depends on, again, the part of the world. The European Union has a more proactive approach, like a more guilty until proven innocent approach, whereas it's the opposite in the US. So a lot of time goes away in just gathering evidence from the literature. A lot of analysis methods are not standardized for these chemicals, especially if they're coming from academic research labs. They are not um, they are not bound to following a certain process. So in the name of research, they can kind of introduce certain steps in the testing processes for chemicals, which we need to interpret those results very carefully. So for example, if I had to compare my results with another lab, are the results matching? Are they reproducible? And then collectively, what does the evidence say? Does it agree or does it disagree? So there is one part of that is like, does the evidence agree that we are all finding these chemicals? And then there's collecting the health effects evidence, which is a whole different beast. I'm not very, very familiar with that, but I think that's where that might be the bottleneck, is like, how do we prove reasonably enough that these are the health effects that are caused, because a lot of toxicological studies are conducted on animals. So extrapolating that to human effects can sometimes be tricky. Although I think we are making do with animal studies for the most part, but those are some of the bottlenecks.
So do you observe that there is, a rising concern about these chemicals ending up in rivers and lakes? And do you
Yeah,
see
I think
the concern rising? So where would you see, which group of stakeholders would you see this concern most? Policymakers
yes.
or what? Yeah.
Yeah, so I think there's a lot more consumer awareness now, thanks to social media. People are a lot more aware of what they're being exposed to in the food they eat. At least cooking in Teflon non-stick pans has drastically reduced quite a bit, in at least in my known circles. So um, I think this awareness might certainly push product manufacturers to switch to safer, quote unquote, safer coatings on their products. Um, so, yeah, I think consumer awareness is a very big part of pushing for change. I think, at least in the US, I see that in a lot of the cookware that's being sold now, people are very familiar with the term PFAS, so they say PFAS free on the packaging and everything. So, um, yeah, I think it starts from there, and then hopefully, seems like it's going to be a bottom up approach where consumers
Great.
push manufacturers and then manufacturers. Yeah.
Yes,
Yeah.
that's great. That's how it should be, really. That is a long-lasting effect. So the thought processes of scientists. What I'm trying to understand is that have scientists and technology transfer units, have they thought about alternatives? For example, you've talked about decentralized and decentralized systems, right? And
Yes.
both are as guilty as the other in not being
Mm.
able to getting rid of these pollutants. But has s- I'm just trying to bring in things like when arsenic was a huge problem with water and the deep aquifers, there
Yes.
were there were we turned to very not simple, I would say, but definitely much more natural systems
Yeah.
by which we could get rid of it or
Mm.
much of it. Is there any natural systems of water treatment, like we already have them in place? For example, use of duckweed and water hyacinths and simple lime or reed bed treatments. Do they help in any way with these removal of these plastics?
Yes. To a certain extent, they do. Um, Plant uptake is definitely one of the um, processes that people use. To example, if you have to remediate a contaminated patch of soil, then there are certain plants that you can plant in that patch of land that can absorb all of the PFAS. But these are all very difficult to scale, and if you need continuous treatment, um, the thing with PFAS chemically is that they are a carbon and fluorine bond, which is the strongest chemical bond. So the only way to destroy a PFAS is to heat it at like 700 degrees Celsius. That's the only way you can break the carbon and fluorine bond. And that's what gives them all these amazing non-stick properties, because they're so bound close together. So, some of these natural treatments that are used, they're good for the context that they're used in, but then once the PFAS is in the plant, what do you do with the
The
PFAS
plant itself.
affected plant? Yeah, if you put it in a landfill, that's not going to work out. So I think the biggest puzzle, at least with PFAS, that we're trying to solve is like, how do we permanently destroy it in a way that's not energy intensive, instead of just transferring it from one place to the other. So like from soil to plant, plant to landfill, again landfill, you will get leachate that again goes into the groundwater, or it has to be pumped to a wastewater treatment plant. So definitely there is a lot of pressure to reduce PFAS manufacture. So that seems you have to shut off the tap. So that's the only way.
That's
That is the
yes, I agree. Would you also tell us a little bit about, the chronic? You just started to talk about it, the chronic versus the acute risks, and also focusing on what kind of diseases, infections that we might be ending up with. Yes.
Yeah. So I think I can speak for phthalates.
Yes.
That they are most established to have endocrine disruption effects. So I think the easiest way to think about it is that they are able to mimic the behavior of certain hormones in your body. So certain receptors in your body can mistake the presence of a phthalate for another naturally produced hormone and produce less of it in your body. So because of that, you might experience deficiency. So this is still a very simplistic way of saying it, but that's what endocrine disruption means. And I think this has been pretty well established in animal studies, certainly a little bit on the reproductive side in humans, not birth defects, I think it is certain early birth characteristics, which are escaping me right now. But largely, the concerns are reproductive and hormonal, which you may not know of until you have a child or until you try to have a child. So, in that sense, these are more chronic, and because we are concerned of their presence in drinking water and especially in women's products that are targeted to women like cosmetics, lipsticks, fragrances, makeup. Those are primary, concerns of exposure. So, other than drinking water, which affects everyone the same, women experience a higher risk of exposure just because of the products that they may feel compelled to use. Like today, I keep telling everyone that even though I study phthalates, I still put on lipstick before every talk. So it's very hard to break out of some habits. But I always make sure to wipe off the lipstick before I eat my food. So you can do certain things to reduce your exposure. It's all about how uh, you know uh, informed exposure, I guess. So yeah, so those are the more chronic effects. I've definitely stopped using some like non-stick cookware. I don't like spray perfume close to my inhalation. So there are some things that will change, like the way you act, the more you read about phthalates. So that's definitely something to think about for whoever is watching this.
Right.
Yeah,
Yes. So we are reaching the close of the program right now, and I know that Mansi would definitely like to come in here and also interact with Meghna. So over to you, Mansi.
Thank you. Thank you so much, Meghna, and especially because I was really looking forward to how you are going to explain this difficult phenomena, and especially curious about which Sonia asked, that coming from a civil engineering background, getting into chemistry, and now trying to explain to people like me who have no ABC and XYZ of both of the disciplines. But having said that, you really made it so simple for us to understand. And I would like to start
thank
with
you.
a couple of questions and
Yeah.
more methodological and philosophical questions, which you touched very briefly. That even we have to we have to make informed choices. We may not be able to get rid of it. And interestingly, one of my research is happening on looking at tracking and tackling plastic pollution in Ganga. And we do talk about the 7 types of plastic typical, like
Yes.
because we are focusing on more community aspects and their perceptions and preference. We are looking at those PET, HDP, PVC,
Yes.
or LDP, PP, or PS, and the other types of plastics, and how terrible it is now with the way the lifestyle and the consumption of all kinds of PFAS you talk about, and the very fact that the plastics evolution is to protect the environment, now we sit in a situation that plastic is the biggest threat to environment. And when you were explaining the method of the different treatment stages, primary, secondary, and tertiary, and you made a very striking observation in your research, and for me that is very enlightening, that inorganic and organic matters behave differently with phthalate, and then you showed it with the diagram. And I'm just wondering then what are we doing with this primary, secondary, tertiary treatment? Because eventually, if the phthalates are going into the water body and we say that it is a treated water body, and we know now that most of the fishes are plagued with plastic filled in their tummies, we know land animals are facing the same, from cow to
Mm.
hen to everyone.
Mm.
And you also mentioned, so I'm kind of summarizing also because it's also coming towards the close. You also
Sure.
did mention that when we wish to treat these kind of components, it's something like, as I wrote in the chat box also, you want to solve one problem, you bring another problem. So it's actually
Yeah.
then 1+1 problem. It's not really one problem.
Yes.
So having said that, you still have to continue finding solutions.
Yes.
And
Yes, exactly.
when we look at the way we actually evolved plastic into our everyday life, there is no going back of it. Whether we talk about the macro plastic or the micro or nano. And probably I would like to first ask you a question. Will this kind of scholarship fall under the emerging pollutants, or it will be called as a micro or nano plastic pollution studies? Because when I'm doing this plastic study, we are actually looking at the naked eye visible plastic. We are not studying nano and emerging pollutants in our
Yes.
study because we are engaging community to seek their perception and preference. Why? So we did Dev Prayag, we did Haridwar, and we did Kolkata, and we asked people very bluntly, their consumption of plastic, and also we did some, of course, field measurements and everything. What is their take and how do they think they can reduce plastic in their life? So, is it part of emerging pollutants? Because we do not have answers for most of the emerging pollutants yet.
Mm.
And
I
do you,
think,
yeah,
yeah,
go ahead,
sorry.
please. Yeah, no, go ahead.
Yes. So, I would say that, yeah, I think this research would come under emerging pollutants because I think macro and microplastic and nanoplastics is still characterizing the plastic polymer itself, whereas
Yes,
this deals with the additive. So I think it would even like the analytical techniques that you would use in a lab to study both are vastly very different. In macro and microplastic research, you're very focused on the size of the
yes,
plastic that you're finding. And these emerging contaminants are definitely present at the nano and micro scale. Hopefully not in the milligram scale, because then we're in serious trouble. But I think for the most part, um, yeah, I would classify this as emerging contaminants research.
So and we are also saying, because India is also now investing a lot on emerging pollutant studies and all. I know some of our friends from Wiki Water Resource Council, they are working on this, especially I can name them as well, Dr. Paromita and you know, Gama Consultants. I have Dr. Girja Bharat. They are really investing a lot of time and energy into it. But if we are in that stage where we are continuously producing, and you also mentioned that scaling up is a problem when you do lab experiments, and even if the lab experiments are done across the world, scaling it up and bringing it to one level, to one consensual level, and then there's the next step of getting influencing the policy,
Yeah.
how they can change it. So Sonia had a very interesting question that how is it regulated? And you did give an example of United States. And in India, I don't know where do we stand today. So I will be very keen to enlighten myself to understand where do we stand today for emerging pollutants in terms of regulations,
Yeah, so that is something
Hyderabad, you are from Hyderabad. Oh my God, so polluted lakes and rivers.
yes, exactly. I was going to say the same thing.
Yes.
Unfortunately, I'm not very familiar with the Indian regulatory landscape, but I do keep visiting the CPCB website from time to time, and
Yes.
I do follow Down to Earth magazine. So from what I know so far, I don't think emerging contaminants are that big of a priority on the regulatory level. I know that there is the Namami Gange project and all of those things. I think before we get to the emerging contaminants, there seems to be a lot more pressing issues to deal with over there. There's also industrial effluents discharge that
Yes.
we probably need to look at. I know that it's a problem in the Yamuna River, even in places like Kolkata. In Hyderabad, I've actually seen a lot of research papers coming up on pharmaceutical pollution, actually, because there's a big pharmaceutical manufacturing
Yes.
industry in Hyderabad. So there are some monitoring studies that have been done on what are these factories discharging as effluent into Hyderabad's water. So I think there is, at least on the research side, this is picking up a little bit.
Yeah, I have another concern as a lay person or community. I must ask it here. Now we all know there is a problem with plastic pollution in our everyday life. We cannot escape it. We also know, in the sense that we can escape not using it enough
Yes,
is as a physical entity in the house. But I don't
yes,
see that we really are left with choices as in direct consumption into our body.
yeah,
When we know that we have reached a stage where mother's milk is also showing plastic components.
yeah.
Every human being is carrying plastic, and of course, as long as we continue fossil fuel, it is going to stay there. That is also established fact. uh, and you did mention that you have to make informed choices. But when you do these kind of lab experiments, and you are going to publish this work, and you have published in the past also, and with your right, how do you think common people will get to understand it better? Because it is all now about informed choices. So
Yes.
you can reduce your consumption, and I think that itself is a transition step.
Hmm.
So how is science influencing community behavior? Where do you see this difficult scientific work is reaching the last mile? I will consider myself in the last mile. That
Yes.
am I informed? I mean, I am not actually, because I'm myself is doing a research on plastic, so I'm not last mile. But just putting it like
Yeah.
a grandmother, my mother, how can she be informed? Every cream we put is also having pellets
Hmm.
to large extent.
Yes. Yes. So that's definitely an area of interest for me. I'm also I do question the fact that maybe people still maybe there's a big chunk of population that still doesn't know the harmful effects of plastic. Like I have been to Haridwar and Rishikesh and those places. Um, I wonder if um, in the name of supporting local economies, maybe people don't want to curb the use of certain plastics. Um, so I think that's definitely a great question for a social scientist, maybe. But I would love to actually find out if people really know that plastic is harmful. Like, I know that maybe people who work with cattle might have seen, but I don't know if the cattle are protected, then maybe they're not eating plastic. So maybe
Oh,
some.
cattle are getting too much plastic. 70 to
e-
80 kilos last year. One cow was dissected.
Mm,
A dog dissected with 20 kilos plastic. So, but those are,
yeah.
we are talking about the macro and microplastics, you know.
Yes. Yes.
But I think
Yeah.
these nano and emerging plastics are very dangerous in that sense, but because they are not visible through the naked eyes.
Mm,
And
yeah.
that
So
is what
I'm.
the emerging pollutant scholarship is talking about. If you don't see your
Yes.
enemy, how will you fight it? I mean, I'm just putting it in a layperson language.
Yeah.
When you see your enemy, you still have a chance to strategize your fight against that enemy.
Yes.
So
Yes.
that's
Absolutely.
anyway. These kind of conversations can keep on flowing, and I think it for every scientist, the most pressing question is how do you really bring your science to the society?
Yeah.
How can you make a difference with this little study or the large study? It's not the scale of the study, but then because it is so important in everyday society. I'm sure you also have a community of researchers who are working on it. I would be very keen to know from you if water pollution and departments like yours are also talking about water epidemics. If plastic epidemic itself is a scholarship by its own merits, it should be like even water epidemics has not risen as a scholarship so much. I mean, from one of my other research on water anxiety, I keep looking for water epidemics scholarship. It is not an established field yet. So is plastic epidemics an established field, or plastics is studied only as a chemical component or other component? Because the moment you talk about epidemics, you're actually talking about health specialists, doctors to get into the study and collaborate with people like you who are actually looking at the physical composition of it.
Mm. Yes, in my experience, I have not worked much with healthcare folks, but I know that in the beginning of this study, we were trying to work with one medical researcher who had urine samples, I believe, from a certain section of people, and we wanted to test that for phthalate metabolites. So the human body actually does transform. When you ingest phthalates, it transforms it into a different chemical, which acts as a marker for us to check if a
Oh,
certain person has been exposed to the phthalate chemical or not, which is usually found in urine samples. So we were trying to work with, but our lab was still new, so we never ended up pursuing it. But I know that if people who do work together, this is how they would do it, is like
absolutely.
figure out the best way to find an exposure marker, and then work with epidemiologists.
Yeah, I think we need more and more multidisciplinary scholarship. And to be honest, in our series here, we have struggled to run sessions on water epidemics, to get health specialists and talk about public health. Because if we really want to change the way we behave with water, it has to be the health component that can bring
Yeah.
a societal change. We are struggling. I will be very honest on that. We barely managed to run the show on water anxiety, which is another level of health issue because it is not a physical part of the health. But we would definitely like to touch upon these aspects and run a water epidemic series, and definitely see how cross-disciplinary work and how physical scientists work, natural scientists can work with social scientists and medical scientists for that matter. And
Yes.
this is just a wish and dream. We can continue talking about it, but
Absolutely.
here,
No, I share
yeah.
that dream with you.
Yeah, so we can work together and find something to do or work on it. And that's the whole idea, that at Wednesdays for Water and at Friday Waters, we are trying to find the gaps. And the moment we identify the gaps, I see that there are more rooms to find out work. And there are people probably working on it. We just need to connect the dots. And
Yes.
at W4W, we have been trying to connect the dots. This is also a moment to also say thanks to Sonia for being here for so many sessions and conducting it so smoothly. And thanks, Meghna, for the wonderful session. Do join
Thank
us
you.
next Friday Waters on April 17th. We are actually taking Friday Water Talkies. And we have a film on Rajasthan ki Rajat Boonde with the filmmaker Amit Tiwari, who is based out of Delft, Netherlands. And we are looking forward to it. Otherwise, W4W is going so slow these days because it's on a reflective mode, regenerative mode for some time, to return stronger with a new look, new team, not new as in, but new people joining us, stronger team, lot of young folks joining us. So we are looking forward to having very types of conversations using different tools and different approaches. So do stay tuned with us at www.w4w.in for more details. And we will keep sharing our updates here. And thank you so much, Meghna, and welcome to our family called W4W. Thanks a lot.
Thank you so
Take
much. So happy to be here.
Thank you.
Thank
Thank you
you.
so much, Megha. Thank you so much, Mansi.
Bye-bye.
Bye-bye. Have a good
Thank
evening.
you.
Bye-bye.